Good afternoon and welcome to the session number 22 from the chapter of heat and thermodynamics. The topic is the calculation of the change in the internal energy of a gas when heat is supplied. So based on this topic, I have one question for this session which is written here on this board. And the question here is, a gas under a constant pressure of 4.5 into 10 to the power 5 Pascal changes its volume from 0.5 cubic meter to 2 cubic meter when 800 kilojoules of heat is supplied. So the change in the internal energy of the gas will be, तो यहाँ पर चार options हैं हमारे पास में and we have to find the correct option. So this session is based on this session in which we have studied about the first law of thermodynamics. So as per the first law of thermodynamics, delta Q is equal to delta U plus delta W. Now delta Q is the amount of heat supplied, delta U is the change in the internal energy of that substance, and delta W is the work done. Now here the gas is expanding because the volume is increasing from 0.5 cubic meter to 2 cubic meter. So when the gas is expanding, so in this case the work done will be positive. Since the heat is being supplied, so delta Q will also be positive. So this equation can further be written as delta Q is equal to delta U and the work done is equal to P delta V. Here P is equal to 4.5 into 10 to the power 5 Pascal, and here the work done will be equal to this pressure multiplied by the change in the volume. So from here, this delta U, which is the change in the internal energy of this gas, this will be equal to delta Q minus P delta V. Now delta Q is already given to us, that is the amount of heat supplied is 800 kilojoules. So this can be written as 800. Now this is in kilojoules, so I will be converting it into joules. So this is equal to 800 into 10 to the power 3 joules minus. Now the pressure is given in Pascal, that is 4.5 into 10 to the power 5. Now we know that this 1 Pascal is equal to 1 Newton per meter square. So if I multiply this pressure with this change in the volume, I will be getting the amount of work done in joules, because 1 Newton per meter square multiplied by the unit of the change in the volume, this will be equal to this meter cube. So finally the unit of this P delta V will be Newton meter, and 1 Newton meter is equal to 1 joule. So the unit of this work done will be in joules. So this is in joules. So here the change in the volume will be equal to 2.0 minus 0.5. This is equal to 1.5. So finally the change in the internal energy of this gas will be equal to, this is this 10 to the power 3 can be taken as common. So this is 800 minus, this will be equal to 4.5 into 1.5 into 10 to the power 2, which is equal to 100. 4.5 into 1.5 into 100. This is equal to 675. So the change in the internal energy of this gas will be equal to, this is equal to 125 into 10 to the power 3 joules, and this is equal to 125,000 joules, and in kilojoule this will be equal to 100 and 25 kilojoules. So the correct option here is B. So in this question, we have to simply use the first law of thermodynamics, and by using this first law, we were able to find the change in the internal energy of this gas. So in the next session, that is in the session number 23, I will be again continuing with I will be taking up one simple numerical problem from the first law of thermodynamics. So till then, have a nice day. Bye.